Section 6.5 is solving open sentences with absolute values. First of all, we're going to look at what an absolute value is and make sure we understand what that is. The absolute value of A is talking about the distance away from 0 that a function can be, or not a function, that a number can be. So the absolute value, the absolute value of A has two choices. This is saying that it has, so what number is a distance of 3 away from 0? Well, if I go 3 away from 0, I get positive 3 if I'm going to the right. Or if I go to the left, I get negative 3. So this actually has two answers. A is either negative 3 or it's positive 3. So let's look at what that does when we have an inequality. And again, we'll continue to solve this. So we'll solve, all right, the absolute value of A minus 4 equals 3. All right, so now we got to figure out, whoops, there we go. Well, now we got to figure out what value for A makes our absolute value 3. So makes our distance away from it 3. So inside of here, A minus 4 has to equal 3, or what we found out earlier, inside that parentheses had to equal negative 3. There's two answers in that case. So since there's two answers, we have two cases. And that first case is where we leave this alone. It's going to be a distance of 3. Or where the inside has the negative distance away, the opposite distance, going in the other direction. A negative sign just denotes direction. All right, and I think I've explained this to you before, but if you think about a football player that punts the ball or kicks the ball and it goes up and the wind blows it backwards and it lands behind him. Well, this football player, his kick had distance, okay? It had a distance, and then say it landed negative 10 yards back 10 yards. It had a distance. It went 10 yards, but this negative just shows that in what direction it went. So when we're talking about an absolute value, we're talking about distances, and in this case, it has two differences. One in the positive direction, which would be moving to the right, and one in the negative direction, which would be moving to the left here in the negative direction. It's still going a total distance of 3. Going 10 yards this way is the same as going 10 yards back. They're both the same distances, all right? But this negative sign just indicates what direction it is going, all right? So we need to solve two cases here, and again, we're just going to get A by itself. So A, we're going to add 4, so A equals 7, or A equals 1. And in both cases, this works. If I plug in 1 minus 4 is a negative 3. The absolute value of negative 3 is 3. 7 minus 4 is 3. The absolute value of 3 is 3. Okay? So in this case right here, the absolute value of B plus 6. So the absolute value of B plus 6, we need to solve two cases. One where the distance inside of this is 5, and one where the distance inside of this is negative 5. All right, so again, we subtract 6. So B equals negative 1 in this case, and subtract 6. And B equals negative 11 in this case. Now, the same thing holds true with inequalities. So now instead we have an inequality here. All right. So now instead of an equal sign, we have a less than sign here. We're still going to have to solve two cases, and the only difference is what we're going to do is we're going to flip this sign. So again, we got to solve two cases. We got to solve when t plus 5 is less than 9. And then the other case we need to solve is when t plus 5 is greater than negative 9. Notice what we did. Here's the change. Here's the asterisk you need to put in your notes. I changed the signs. And I changed both of them. This one and this one. All right, we flip it and we change the sign. We solve both cases. All right, so we're going to solve both cases. Subtract 5. So t is less than 9. Or sorry, wow, I never subtracted. T is less than 4. And I'm going to subtract 5 here. T is greater than negative 14. And then it says graph the solution. And why do we graph? Because we graph to tell whether it's an and statement or it's an or statement. So I have an open circle at 4. I'm shading to the left. And I have an open circle at, ooh, wow, I made that wrong. That's a negative 14, isn't it? So maybe let's do this. Let's just do, wow, I'm going to completely erase that graph because I messed that up. Sorry about that. So we're going to make our number line. And sorry, I have a negative 14 here, and I have a 4 here. And again, they're both open circles. However, in this one, I am shading, it says t is greater than negative 14. I am shading to the right. And here it says t is less than 4. I'm shading to the left. Since they're overlapping, this is an and statement. Okay, since they're overlapping, it has to be an and statement. Okay. So on your own, go ahead in your notes. I would like you to solve those. That equation right there. Absolute value of s minus 3 is less than or equal to 12. Okay. And I'll go through this one actually so you can make sure you did it right. So we need to solve two cases. S minus 3 is less than or equal to 12. And then in our second case, s minus 3 is greater than or equal to negative 12. Again, we flip this sign and change that sign. Solve both cases. Add 3. S is less than or equal to 15. Add 3 over here. S is greater than or equal to negative 9. And again, we graph this thing. And I have 15 here. And I have negative 9 here. Closed circles this time. This is saying I'm graphing to the right. This is saying I'm graphing to the left. Since they're overlapping, this is an and statement. Okay. It's important that we write whether it's an and or just so we can be specific in telling what it is. So again, we're solving two cases. Nothing changes. It's just a little bit more of a multi-step one. All right. So 2x plus 8 is greater than or equal to 6. And our second case is 2x plus 8 is less than or equal to negative 6. Okay. We have to flip this, change the sign, and we're dealing with inequalities. All right. So again, solve. Subtract 8. 2x is greater than or equal to negative 2. Divide by 2. I'm not dividing by a negative, so I don't have to flip my sign. X is greater than or equal to negative 1. In this case, we're going to subtract 8. 2x is less than or equal to negative 14. Divide by 2. X is less than or equal to negative 7. And then it says to graph as well. I'm going to graph up here because I was running out of room down below. I have negative 7 and I have negative 1. They're both closed circles. Negative 1 is shading to the right. Negative 7 is shading to the left. They do not overlap, so that has to be an or statement. It is an or statement. Okay. And again, last one here is for you to try on your own. Make sure you do it right. I'm going to show you right here so you can check your work and see where you made a mistake. So we have two cases. 3y minus 3 is greater than 9. And then 3y minus 3 is less than negative 9. We need to solve by getting the variable by itself. So we're going to add 3. 3y is greater than 12. Divide by 3. Y is greater than 4. And in here we're going to add 3. 3y is less than negative 6. Divide by 3. Y is less than negative 2. And then to graph this thing, we have a 4 and we have a negative 2. Open circles on these guys. It says negative 2 is shading to the left. Y is greater than 4 is shading to the right. They don't overlap, so therefore we have an or statement. Hope this helps. We'll see you in class.